Welcome back to the another session of our data structure journey. We are right now doing the series of circular linked list. We are already completed how to create the circular list as well as the display by help of the insert into the first position. Second, we completed that is insert into the last position. Then delete from the first position. Right now we are going to cover delete from the end of the circular linked list, and we are covering the all the algorithms by help of the C language, and we are trying to do in the menu drive program. And each and every video we are just added the one function into our menu drive program, and we have performed the operation. So it will be recommended, or you can think like it's a prerequisite for this video, that you should follow the previous video so that it will be easy. Data structure programs are too long, so it is not possible for a single operation I will do the program. Hope you are understand the things. So what is the algorithm means, or what is the concept behind it, how we can delete the a node or an element from a circular linked list. Circular linked list means that end of the node points to the first node. Then it is called as the circular single linked list. Circular list classified into two types: circular single and circular double. So let us take the what are the possibilities. For example, one case one is that list is empty. If there is no element, then what happened? We have to print a list is empty. Then case two. Case two, that is list is single element. If list is single element, then what we have to do? We have to make the start pointer as well as the last pointer to null after deletion. Maximum program you find that the only start pointer, but I prefer for the last pointer is that whenever any operation you have to do in the last pointer or end of the list, no need to traverse. Direct we can use the last pointer and perform the operation. This is the simple concept, nothing big. If you want, you can do it like that. Single pointer can be possible. So for example, single one element is present. This is 10. Now, this is the start pointer. This is the last pointer. For example, address is 100. So single linked list store the value of null. Right now, single circular single linked list, that's why it points to the same node. So this is the data is present. Now we have to delete last node means only single node means this node we have to delete or this element we have to delete. So first simple, you have to print the data value you want to delete. So how to print? You can go for printf start info or last info you can print. Then you print the value. So you have to print 10 is deleted. Once deletion is over, then what you have to make? You have to make another pointer. You can make as a temp pointer. Temp pointer, or before the deletion you can write down temp info. It can be your choice. Right now temp start last each and everything points to the same value, depend upon the sequence you are writing. If you are make here and there, in case of data structure, data will be lost and you are not able to get the correct answer. So now, for example, temp point to this one. Now what happened? You print del is deleted. Then what happened? You have to make the start equal to null as well as last equal to null. Last equal to null. So then if you make the start equal to null, last equal to null, then what happened? Stop pointing to this node. It's not pointing to. So start and last does not point to anything. After that, what happened? You have to make the free. Free temp means you have to release the memory. So release the memory means whatever memory occupied by the temp, you have to release. So now start which value? Last value. So start as well as the last both points to the normal. So list is empty. So after deletion of single element, list is empty. So this is the things we have to follow whenever there is a single element is present. Next case is that is if more than one element is present. So case three that is list have more than one element. If more than one element, so take an example. For example, this is our circular single linked list is present. These are the nodes. For example, this is the node. Node has two part, information and pointer to the next node, pointer to the next node. Last node points to the first node. This is the concept of circular single linked list. So this is the start. This is the last. For example, 5, 10, 15, 20, 25 data is present. Now, what is our objective? Objective is that to delete the last node. So we have to delete this node. So we have to think what are the procedure we have to follow so that we can able to delete. So here what happened? This is the last node. This node we have to make connection to this one. It is a single linked list. It is not a double linked list. So immediately we can access this node. We cannot access this. That's why we have to traverse this node. So we have to traverse until we are not reached the previous node of the last node. So whenever we are traversing and we reach the value, so at that time what happened? We have to make the previous node pointer as a pre. This one we have to make as a temp. We have to traverse. So initialization, this is the temp. Then we have to traverse all the things. Pre also this one. So initialization pre also this one. Then we have to traverse in such a way that temp points to the last node, pre points to the previous of last node. Once we reach this value, then what we have to do? We have to make a connection. This pre next should be connect to last node. Then it is a circular linked list or not. So this one is done. We have to make the connection. Then we have to make this previously last node point to this node. Then you have to make this last node point to this node. So this connection is gone. After that, you have to write down the release of this memory, release of temp. So once you make the release of temp means right now this is last point to this one. So for example, this is gone. Then what happened? Then you have to release the temp. So once you release the temp, then what happened? This node is gone means this connection also gone. Now, so now this is the now this is our circular single linked list. Deletion of last node is success. So this is the algorithm. If linked list is empty, print the deletion not possible and exit. Otherwise means we have to check whether a single element or more than one element. Reason is that if single element, then last pointer also we have to make as a null. So if the list of single element, then print the value to be deleted and release the start pointer and make the start as well as the last as a null pointer. Simple. It is the same as the deletion from the first node for the first case. Deletion in the first end, we also consider these two cases is same. Only this third case we have to consider. If list have more than one element, make the temp pointer point to the start. Traverse the end of the linked list and make the pre pointer as a previous node of the last node. Then make the next pointer of previous node to the last point means we have to connect to the start node to make a circular linked list. Then make the previous node pre as a last node and release the memory. After that, our deletion is successful. So this is the simple algorithm we have to follow to delete a node or element from the last of a circular linked list. So this is our menu drive program. We are already started from the previous video. So this is the series. So here we are just going to add one function, that is delete list. Delete begin is the same, only this else statement we have to change. So let me copy this one and we just make the changes. No need to write down so many things because only more than element we have to change it. So begin, we have to change the function name as a end. If start equal to none, list is empty. Else if start next equal to start means it is a single element, we have to delete and release the memory, make the start as a last. So same thing here we have to do, only this thing we have to change it. So first part we have to do, we have to make the temp pointer store the value of start, then we have to traverse to reach the previous node of the last node. So while temp not equal to last, we have to make the pre equal to temp, temp equal to temp next, because previous node we need, that's why we make this way. So we are not mention what is pre, so we have to write down pre, it is a pointer. Once we reach the previous node, then we have to make the previous node next to new node. Not to new node, this is to the first node. We have to make a circle. So pre next equal to start. We make a circle right now here. We make a loop here. Then pre node we make as a last node. So last node we make as a pre. So here the connection is established. Only we have to print the deleted value and release the memory. Then which value? That is the temp info. Then free the temp. So this is our delete and end is over. Right now we have to add the condition in our menu drive program, that the 4 is for display. Okay, 4 we have to make the delete from end. This is 4, then this is 5, this is 5, then this is 6. Okay, this is also you have to make as a 6. Then here we have to add one more condition. This is 4, this is 5, this is 6. Let us compile the program and run the program. No error code. So here one is for insert, delete. Okay. Now first we have to create the linked list. Otherwise, if I go for the deletion from end, it will be display list is empty. So first we have to add the value for 10, then 20, then 30, then 40. Let us display the linked list. Display is 5. So now elements are 10, 20, 30, 40, 50. Because we go for 2, that is the insert in the last position. So it is sequentially, it is printed. Now we have to delete from the end, means 50 is going to delete. Which one is? That is the 4. 50 deleted. We got correct answer, 50 deleted here. Then 10, 40 is deleted because first we are already deleted 50. Now we deleted 40. If I go for again delete, then 30, because after 40, 30 is present. For example, I go for display. Right now only 10 and 20 is present. If I go for delete begin, previously we are already done it. Delete begin, that is 10. Again I go for delete from the first position, that is third. 20 deleted. Right now list is empty. If I go for third, list is empty. So delete from first as well as the delete from end is, we have got the correct answer. Delete from begin, we are already completed in our previous video. In description section, I also put the link so that you can go for it. So hope you are able to understand the concept. So this is our complete program. This is for structure declaration. insert in the first position. Then we have to go for display or insert in the last position, begin position. This is the code. Today we just cover this one. So here, if list is empty, we have to check start equal to null. Then we have to print list. If single element start next equal to start, we have to make. So let us understand this code. So first, what happened? This is number of node is present. Let us take the only 4 element is present, 200, 300. This is 400. Data is present, 10, 20, 30, 40. So connection is established. Connection established means they store the 200, they store the 300, they store the 400, then they store the 100. So circular linked list is over. Start store which value? 100. This is last store which value right now? 400. So this is the circular linked list is given. We have to delete from the end position, means we want to delete this node. We want to delete which node? This node we want to delete. So this is our main objective in this program. So here what happened? Else means this code we have to execute node temp equal to start. So now what happened? Temp point to this node. Which node? This node. Node equal node pre. So we define a pointer that is the pre. While temp is not equal to last. What is temp? What is last? 400. What is temp? Temp is right now 100. So 100 is not equal to 400. Yes, it is true. If it is true, then the body of the loop will be executed. Now, temp value stored inside the pre. What is the temp value? 100. Now, pre. So pre means this one. So pre store which value? This value. So now temp store which value? 200. No, sorry, 100. Pre also store which value? 100. Then temp equal to temp next. Temp next is 200. Now temp store which value? 200. If temp store the 200 value, it means that now this connection is gone. This connection is gone. Now temp point to which one? Now temp point to this node because it is 200. Then it go to starting. While temp is not equal to last, 200 is not equal to 400. Yes, it is true. If it is true, then temp value stored inside the pre. What is the temp value? 100. Store in which value? 200. 200 means what? Right now it's point to this one. So now this connection is gone. Once this connection is gone means what? Pre points to this one because pre is 200. Then temp equal to temp next. Temp value is 200. 200 next is 300. So it is 300 means right now temp point to which node? This node. Then temp is not equal to last. Temp is 300. 300 is not equal to 400. Yes, it is true. If it is true means temp equal to temp stored the value in pre. Pre what is 200? What is temp? 3. 300. So it stored the 300. If it is 300 means what? Right now, this connection is gone. Right now, pre point to which node? This node. Then temp equal to temp next. 300 next is 400. So now, temp, this connection is gone. Now this is temp. Now this is temp. So temp is equal, not equal to last. No, right now it is true. So this loop is not going to execute. Now next line, pre next. What is pre? 300, 300, 300 next. Right now it is 400. Store which value? Start value. What is the start value? 100. So what we have to do? We have to make this value gone. Right now it store the which value? 100. If it is 100 means now pointer points to this node. Then pre equal to last. Pre equal to last means, sorry, pre value stored inside the last. Last is pre 400. Right now what happened? Last pointer points which value, store which value? That is 300. If it is stored 300 means now this is last. Last means this connection is gone or not? This connection is gone. Then print a percent d deleted temp info. What is temp? Temp equal this one. So info 40. So output will be display 40 deleted. Then free temp means this memory we have to delete. So here if we delete temp, so we are going to delete. So if once the deletion means what happened? Its connection also gone or not? So once the connection is gone means what? Now deletion at the end position is gone. So this is our main function. We are adding one more condition here. Thanks for watching the video. Please subscribe the channel as well as like and share the channel. Thank you so much.